Hello everybody and welcome to the Unit 3 of the ROS Manipulation in 5 days course. In this unit we are going to see how to do motion planning programmatically. So in the previous unit you saw how you can build a movie package and how you can perform some motion planning using Moveit. But in this unit we are going to see how you can do that using code. In this case we are going to do it with Python code. Okay? So let's start. First of all, before even starting with explanations, you have one exercise, which is to create a movie package of this for this fetch robot, for the arm of the fetch robot. Okay. Then in the previous unit you learned how you can build a movie package. So now you have to apply this knowledge in order to build a movie package for this fetch robot, for the robotic arm of the fetch robot. Okay. You have here a couple of predefined positions that you will need to define. I have here my package already created, okay? So, this is the first. Do this, and then we'll continue with the unit, okay? So, see you now. Are you done? Excellent. So, when you have finished it, you should be able to launch a movie package that looks somehow something like this, okay? With the robotic arm in orange and, well, more or less something like this, okay? Then, now, also, before starting doing the motion plans, we are going to do one thing. We are going to execute this command here in order to raise fetch torso. This way it will be easier to do motions, okay? Because now, as you can see, the arm is almost touching the base of the fetch robot. So we are going to raise the torso so everything is easier and smoother. Okay, so let's execute this command here. ROS launch fetch gazebo demo move torso dot launch, and we wait a few seconds until the torso of the fetch robot is raised. Okay, it will look something like this. There it is. It's starting to go up. So let's wait until it is fully up. There you go. Okay, it has finished the motion, so we can now stop this. And let's begin. Okay, so the first thing you will need to do is to launch your the package you have created for the movie package you have created for fetch robot. You will have to launch the planning execution launch. Okay, so if you remember from the previous unit, at the end you created a planning execution launch. So you will need to launch this one. Okay, here it has some names, but depending on how you name the launch file, how you name the movie package, it will be different. Okay, here it is said in the notes. So yeah, in my case, for instance, it is ROS launch test moveit config fetch planning execution. Okay, this is the command for launching my moveit setup. So I'm going to execute this command. Now let's open a graphical interface window by hitting in this icon. And there we have it. As you can see, it appears here a little bit moved. So we are going to execute the command you saw in the previous unit in order to center a little bit this. So if you remember, it was this one, yes? So let's execute this command here, and this will be centered. Excellent. So here we have it. We have our fetch robot with the robotic arm in Moveit. Excellent. You should have also something like this, okay? Now, in the previous unit, we came here to the planning tab and we were planning trajectories here, executing trajectories, whatever, okay? Now we are going to forget about this planning tab and we are going to plan a motion using Python code. Okay, so first of all, let's come here, select this cell with the Python code and click the play button in order to run this Python code. So let's go. I'm running this Python code. And now, if I come here, I can see that it has started planning a trajectory in MoveIt. Okay? The robot, though, is not moving. So the robot in the simulation is not doing anything. But here in MoveIt, it starts to show me a plan of a trajectory, as you can see. Okay? Very interesting. Then, what's going on here? Yeah, here you have the motion planned. Okay, so basically let's now analyze a little bit this code. So what does this code do? First we have a section with some imports, okay, some messages that we need, and the MoveIt commander module, okay, which this module, this here, is the one that allows us to communicate with RBs, okay? This MoveIt commander module. The other are just ROSPy, as you can see, syscopy, and some messages that we will need, okay? Then we initialize here the MoveIt commander, okay, with this line of code here. Then we initiate a node, as always. Always in ROS, you have to start initiating a node, okay? So here we create our node. Then here, in this line here, we create a robot commander object, okay? Which basically is an interface to our robot. Yeah, will let us talk to our robot, okay? So here we are creating this MoveIt commander object. Then, as well, we create an object of the planning scene interface, okay? So here we create let's say an interface for our robot, and here we create an interface for the scene. Yes? In this case, the scene is not that important because we just have the robot, but in the next unit you will see that the scene also affects, okay, in the motion plannings. Excellent. Then here, so here what we are doing is to create a move group commander object, okay, and we pass here the arm word, okay? So what does this mean? This basically is creating an interface so that we can communicate with the planning group of our arm. Yes? So when I define in the MoveIt setup assistant, you remember, you had to define a planning group. So when I define the planning group for my arm, I give it a name. In this case, the name of this planning group is arm. Okay? So this is very important. Yeah? When you create the MoveIt package for your fetch robot, you will have to call your planning group for the arm like this, arm. Okay? And this is basically creating an object of this. It is creating an interface that will let us communicate with this planning group. Will let us send him orders. Okay? Then, yeah, here we are defining a publisher which will let us visualize the planning in MoveIt. Yeah, so it is publishing into this topic, the move group display planet path, and basically this topic what does is to show us the plan in MoveIt. Yeah, this plan we can visualize it thanks to this topic. Yeah, so here it is basically creating a publisher of this, and finally here comes the most important part. Here we are defining the goal we want. Okay, a goal pose. Yeah, so we are defining a pose for our end effector. Yes, so here we are defining an X, a Y, a Z, and an orientation W, and this basically defines a pose of the end effector of the robot. Okay, then in order to reach that goal pose, it has to perform some motions. Okay, and this is what I am visualizing here. Okay, but what I am defining in the Python code in this case is a pose goal for the end effector. Yeah, the end effector, remember, is this hand, the hand here, this gripper of the fetch robot. Yeah, let's then, yeah, here we have it. This here is the end effector. Okay, so what we are doing here is defining a goal for this end effector. Yeah, then in order to reach that goal pose, Moveit will have to plan a trajectory. Okay, excellent. Then here basically I'm saying to plan this trajectory, I'm sending an order to plan, to make a plan to reach that pose goal, and finally I shoot down the Moveit commander. Okay, so this is basically this code here explained line by line. Okay, excellent. Then, is this the only way I can plan in Moveit with code? No, there are many ways. Okay, this is a way which is passing a pose goal for the end effector. Okay, we are going to see another one now. Anyways, there are many more. Okay, well, not many more, but there are some more. But in this course, we are going to see this one, and we are going to see later this one, the planning to adjoint the space goal. Okay, before going to this section, you have here an exercise, a very easy exercise, which is to put this code here into a Python file and launch it. Okay, so you create a package where you put this code inside. So this way you will be able to change values here, to play a little bit with the code and test how this works. Okay, you can change the values here, you can add more plans if you want. You can do whatever you want with the code, okay? But for that you will have to put it in a Python file. Yeah. So basically this is what it says here. Yeah. Of course you need to have the fetch planning execution launch file running. Yes. If you don't have this running, it won't work. Okay. Then yeah, basically, so create a new package called my motion scripts. You create a script which is planning a script.py, and you paste the code you have used here into this script. And then here you can modify the values assigned to the post target variable. You can modify the values here. You can play with the code. Okay, so that's the purpose of this exercise. Then when you finish when you Control-C your program with the plan, probably you will see an error like this. Okay, but this is normal. This is a known issue, and it is because it has some problems when it has to shoot down. But this is normal. This is a known issue, and it's nothing wrong. So it doesn't affect in anything. You don't have to worry about this. Okay, here it is warning you about this. Okay, excellent. So let's make sure that this is stopped. It's not running. Okay, I'm going to restart the kernel as well, just in case. Then, excellent. Let's move to the next section, which is here, planning to adjoint space goal. So here we have another quick demonstration. So first of all, we need to launch again this command. I already have it here, but I'm going to restart it so that it starts everything from zero. Let's launch again this. There we are. Probably if you do the exercise, you will stop and start this command many times. So I'm going to do it all from zero again. Then let's see. There we are. Then let's again center this. Excellent. So now these are started from zero, and what you are going to do now is to execute this code here, okay? So again, let's hit here, select the cell, and hit here into the play button. You can also shift enter, okay? Whatever you want. So I'm going to play this code, and now let's come here to move it. There we are, and I can see another plan now. So you can see, here it is basically moving down the end effector. It's just moving one joint, in fact, this one here. It is rotating this joint. If you check this motion, it is just affecting one joint. So, great. Yeah, here we have a GIF showing what it should do, what you should see here in Move It. Yeah, as you can see, it's the same. Then, this code is a little bit different, okay? It has many things that are the same, but it has some changes. Basically, all of these, the imports are the same, this is the same, this is also the same, where it creates the robot commander object, planning scene interface object, the move group commander object, all of this is the same, okay? But then here there are a couple of different things, which is what we are going to analyze here. First of all, we have this group clear post target. So basically this is cleaning any possible goal, any possible target that the robot has, okay? So the values here in the post target variable, which we were using in the previous code, if you remember, we had here this post target. It is cleaning this value, okay, because we are not going to use it now, so it is cleaning this value. Then, here, it is getting the value at this moment of the joints, okay? So this function get current joint values. It is quite self-explanatory, but what does is to basically get the current value of the joints of the robot, okay? Just that. Then, here, I am giving to the joint, to the third joint of the arm, a value of 1.5, okay? And I'm setting this joint value as a target. Yeah? So I give a value to one of the joints, in this case it's the third joint, and I'm setting this value as a target for the robot, okay? And finally, I plan a trajectory to satisfy this value. So, the third joint of the robot, obviously, it will be this one here. Yes? It's this joint here. This is the third joint of the arm, okay? This one here. You can check it also in the simulation. This is the third joint, okay? And what I am doing, it is to give to this joint a value of 1.5 and setting this as a target. So in order to get this position, the joint has to rotate doing this movement we can see here in the plan. Okay? Pretty easy, don't you think so? It's very, very similar codes, just a couple of modifications. Okay? Great. So again, you have another exercise where you can pass this code to a Python file and do modifications, change here the joint you want to move. Instead of the third, for instance, you can put here a 1, a 2, whatever you want, okay? You can play a little bit with this code. Okay? Excellent. Then, let's stop all of this. And I continue with the explanation. So here, getting some useful data. So these are some comments that will allow you to get some useful data. For instance, get the planning frame, get the end effector link, the name of the end effector link, get the names of the groups, of the planning groups, get the values, the current value of the joints of the robot, get the current pose of the end effector, or get the current state. This will give you a general state of the robot. Okay? So here you have various commands that you can test. You have here an exercise where you can put all of these into a Python script and see how they work. Yeah? But basically these commands here, what will be very useful in order to get data from the robot. Okay? And then with that data you can do wherever you want. Excellent. So we are almost done. The last part here is to execute a trajectory, because until now we have been planning trajectories in Move-It, but the robot in our simulation, it hasn't moved nothing. Yeah, it stays the same. So what can we do in order to move as well the robot in the simulation? So it's very easy. You have to add this. Yes, you have to add this line here, group dot go and weight to true. Okay, it's very easy. So what you can do, let's test this very quickly. What I'm going to do is to create a package very quickly. Let's do it here. Create package. I'm going to call it move robot. There we have it. Excellent. So inside here I'm going to create a folder, a source folder, and I'm going to put here move robot script.py. Okay? Then inside here, if I want to move the robot, all I have to do is to, for instance, let's get this code. I'm going to paste it here. Excellent. And now all I have to do if I want to move the robot is, for instance, let's comment this line here where I request a plan, and let that this line here. Yeah, so I'm going to add this line here, group go weight true. Yeah, so now let's launch again our Move-It system. There we have it. And now what I'm going to do, well, in order for you to see it better, what I'm going to do is to plan it. Then I'm going to add here a sleep of, I don't know, 5 seconds, and then I'm going to execute it. Okay, this way it will be clearer. So I will plan the trajectory, I will wait for 5 seconds, and then I will execute it. Okay, this is what this code will do. So let's execute our code. ROS run. Sorry, move robot script. There we are. So let's execute this and see what happens. There we are. Okay, so now it is planning the movement, and after a few seconds it will execute this movement here. Let's wait. And there it is. There it is, executing the movement in the simulation. Excellent. So as you can see, in order to execute the trajectory, all you have to do is to add this line in your code. Okay, and this way it will execute, the robot will execute the trajectory. Okay? Excellent. So I think this is all for this unit. Let me check. Yeah, here you have another exercise. You can do it. And finally, here it is also another exercise in order to concatenate at least 2 motions. Yeah, so until now we have been working with just one motion, but at here it asks you to concatenate at least 2 motions. So do one movement and then do another one. Okay, at least 2. Then finally, very important, when you finish with this unit, remember and make sure to return the robot to the home position, which is this one. Okay, so now, since I've been doing tests, as you can see, my robot is not in the home position. Yeah, you can see if you compare it, it has the hand looking down and it has to be facing up. Okay, so when you finish with all of this, return your robot to your home position. Okay, and that's all. See you in the next chapter. Goodbye.